Hey, so I'm Major General retired Brian Watson. I'm out here at the Army Engineer Association's industry exhibit, and this is Regimental Week, and one of the things we get to do during Regimental Week is interface with industry. They come in here, they rub elbows with young leaders, both young officers, young non-commissioned officers, young warrants. And really two things. Number one, they begin to get feedback on the systems that in many cases they've already fielded to the Army. But the other thing they do is they kind of ignite our imagination about what is possible. What do we see coming down the pipe? And so I'm with Qinetiq, and so Bob, it's good to meet you.
Nice to meet you, sir.
Yeah, so I want to talk a little bit. So currently, this system is already in the field, I think about 600 or so. This is Chrissy?
Yes.
Yes, you talk about this system, and then more importantly, what kind of feedback are we getting from soldiers, and what are we doing about that feedback?
Okay, thanks, sir. Yeah, like you said, sir, this is Common Robotic System Individual Programmer Record. Over 600 systems have been fielded to combat engineers and EOD, and also soon to be military police. It's supposed to be small, backpackable robot. Weighs about 30 pounds with the arm, and it can fold up, and everything fits inside of itself. So you can fold everything up.
Cool.
Even the arm folds up inside the robot, which makes it easy to carry in an assault pack when you're going on a mission. Really for dismounted sappers and folks that are out there doing, hazardous missions. So you can use it to do neutralization, like you see of an inert charge on here, or you can do some sort of detection with IEDs that we've been doing with visual detection. It has multiple cameras, a pan tilt zoom camera right here, has a drive camera, front drive camera, and a rear drive camera. And of course the flippers allow it to climb stairs, and it makes it to be very mobile. A lot of the feedback that we're getting from the users, from the fieldings that we've done, they really like the capabilities for just a small package. To be able to go 5 miles an hour through cross terrain, uneven terrain, with the capability that it gives for maneuverability, and it allows them to do their missions when they're on a light dismounted mission. So the replacement for the old PackBot, we've seen PackBots before, so this works as that replacement. And yeah, that's in general the users.
What's the range on it?
So with this radio, this is the radio for the controller. We're able to get out to about 1,500 meters.
Yeah, pretty good.
And that's line of sight.
Yeah.
So non-line of sight, you're talking about 400 to 500 meters.
Okay, yeah, that's really good. So, this is one of the outgrowths of Afghanistan and Iraq, and about that time, robotic technologies were coming. We began to infuse them in the military, and this is really has stuck.
Right.
And now we're at that place where we're looking at, okay, how can we make it even better?
Right.
So if you think about just the platform, and now there's becoming increasing demand to put different sensors on different payloads, but this will still stay predominantly the same. You can put a lot of different things on it.
Right, and also the chemical regimen, this can carry JCAD, multi-array, numerous chemical sensors that you want to put on it, and it's automatically integrated into the controller, and the controller will display all the sensor data and feedback that comes from it. So not only do you have the camera and the optic capability, but you also have the sensor capability that you need out in the field. So,
and the fact that it all is self-contained, I mean, that's fantastic. So now, where do you think, so this is current state, but everybody wants to get smaller, everybody wants to become more portable. So where do you think it's going?
well, there's some discussions right now, and we've developed 2 prototypes of small throwable cargo pocket size systems that could easily be deployed and could complement a system like this in subterranean environments. So if you are going into a cave or a tunnel or somewhere where you need to go and you're losing communications because of all the interference of being underground, you could use these little guys here to be your relays, and you can throw them down when you start losing communication with that robot. You can put these down and create that mesh relay with the radio, and it would help extend the communications downrange under a tunnel, in a culvert, to give you that max distance that you need.
So you know, that becomes a system of systems, but you could put almost anything on here.
Correct.
I mean,
yeah,
beyond just a comms relay, this could be throw it up over the
Right.
wall that you can't see, and you got a camera on there, and you're able to collect.
And one of the ConOps too that's being developed is to be able to deploy this with a quadcopter, so you can pick it up, put it on a rooftop, you can crawl underneath things and look in places. Even if you deploy this, you know, it could be picked up by a quadcopter and dropped off at the entrance to a culvert, and it can go into the culvert, inspect it, because you know, getting UAVs into a culvert is not easy, right?
Exactly.
So it just allows it to do that, and plus, like you said, sir, with the sensors, the cameras, everything that you can put on here.
And so this is a similar version, but now has the ability, probably, to, given the flippers, to handle a little bit rougher terrain.
Right. We noticed that without the flippers, that these are very limited in what it can do because of its size and weight. It can get hung up on rocks really easy. So in some Navy trials, we learned that they would want small flippers on it just to be able to get over that rock or to get over that, whatever that obstacle is that's keeping it from traveling.
But still the ability to mount here a variety of sensors.
Correct. You know, that's one of the requirements that we see coming down the pike as far as, so we're just prepping for it. And we use this, and I even talked to a lot of the Sapper Leader Course guys, the instructors. You know, if we can give them a few of these to be able to use in the course, and then we get that feedback.
And then see how they use
And
it.
see how they use
Right.
them or what they want different. Do you want a thermal on it? Do you not want a thermal?
I swear, you know, soldiers are the most innovative beasts in the world.
Well, that's how we learn.
And sappers are among the most innovative of all soldiers. So I think, you know, getting something like that in the hands of Sapper Leader Course and others, they find ways to use every bit of technology. So thanks for doing that. It's awesome.
And in the design, even in the design of that, was all user feedback. We make prototypes, we give them to the soldiers, they provide the feedback to me. I go back to the engineers in Boston and say, look, take this off, put this on, make this lighter. That's how we develop it.
So that's a great point too, is that, you know, for people that have this system, if there's some things they're seeing, they can get back to you all and say, hey, here's what we're seeing, and you begin to take that on, because you really are focused down in giving the soldier the best possible piece of equipment. Yeah, so, hey Bob, thanks very much, man. I appreciate it. Thanks for taking the time with us.
Sure, thanks.
So, look, another example of some technology that is in your hands now and sort of where it's going, and really important that when these pieces of equipment come to us down in the field, that we are providing as much feedback as we possibly can, because these guys like him, they want to make the best piece of equipment in the hands of soldiers so you can accomplish your mission. Okay, that's it. Thanks very much.